So we just start, few questions are left for the oblique elastic and inelastic collision, right? For example, particle and wedge problem, especially when the particle collides with the wedge at some angle. All right. For example, I'm giving you example one by one. Suppose this is the wedge, movable wedge. This is the trolley. All right. And the mass of this trolley is capital M. Right. This is the circular trolley. Suppose like this. This is the shape. And this is the particle. This particle of mass M is coming with the speed V naught. And this angle is theta. Right. Like this. So this is the mass M is coming like this, and this angle is theta. All right. If it is at rest, it is at rest. This is at rest, and the particle is coming in this way. If collision is perfectly inelastic, you have to find velocity of car. You have to find the velocity of car. Also find loss of kinetic energy. Right? Copy this. So how to solve this question? Okay, so how to solve this question? Listen one thing. If you assume this is the x-axis and this is the y-axis, right? If you consider this is a system, this is the trolley and this is the particle. So when it will hit the ground like this, it will hit, right? The perfectly inelastic collision is there, right? So it will combine with this and they will move as a system, right? The ball and the trolley will move together. All right, they will move together with some velocity, suppose the v dash. This is the m and this is the capital M. If you consider this the system, there is no impulse applied in x direction. In x direction, no impulse is applied, therefore no change in momentum in the x direction. So initial momentum x direction of the system is equal to final momentum in the x direction of the system remains constant. So what is the initial moment? It is at rest. This is mv naught. So in x direction, the momentum, this is the velocity v naught cos theta. So only this particle has the momentum in x direction. Therefore mv naught cos theta plus its momentum, because it is at rest, so it is 0. When they combine, move as a system. So what is the momentum in x direction? M plus mv dash. So what is the v dash? Is equal to mv naught cos theta upon m plus capital M. So this is the velocity, common velocity with which the car will move, right? Now in the second part, the loss of kinetic energy. Loss of kinetic energy mean, because the collision is inelastic, there will be some loss of kinetic energy. So initial kinetic energy is what? Say half m v naught square minus final kinetic energy m plus m into v dash square. If I take half m common, v naught square minus m plus capital M, m v naught cos theta upon m plus capital M whole square. This is 1 by 2 m into v naught square minus m square v naught square cos square theta upon m plus capital M. Take half m v naught square common, there is a 1. This is m cos square theta, right? M cos square theta upon m plus m, right? So if you simplify, then you can get further some expression, m plus capital M minus m cos square theta, right? You may simplify this, half m v naught square. If you take common m plus 1 minus cos square theta it is upon m plus capital M. It may be written as m v naught square m plus small m sine square theta upon m plus small m. So this is the loss of the kinetic energy. What we have done, the perfectly elastic collision, after collision, right, the velocity along the common normal will be 0 and they will stick to each other. In the x direction, they will move with the common velocity. So no impulse in the x direction is applied. Therefore, as a whole, as a system, we are considering, right, when it will hit, the impulse will be applied in this direction. Do you understand or not? Are you getting or not? Right. So no impulse is applied in the x direction. Listen, when it will hit, when something will hit, where will be the impulse is applied? The impulse will be applied on the tire of the trolley in this direction. So this is the ndt you can consider, right? No impulse in the x direction. Therefore, conservation of momentum we can apply on in x direction, right? Okay, so I have sent you one more question. Can you read that question? Can you read that question? One question I have sent. It is from the Cengage itself, right? Also will be given in your book. Can any one of you read that? Uh, hmm. 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 Okay, so this is the question, right? So, okay, so in this question, what we have given, in this question, we have the wedge, right? This is the wedge, and the wedge mass is capital M. A ball, a small ball, is moving with velocity u, right? After collision with the wedge, right? It start moving with the speed v in this direction. The angle is theta, and after collision, the wedge start moving with the speed v. Are you getting or not? So that is the thing. So if you consider this the x-axis and the y-axis, so before collision, suppose if you consider this is the system, when the impulse is applied over here, right, its momentum is change of the ball, and also it start moving in this way. If you consider as a system as a whole, there is the impulse only in y direction. So impulse no impulse is applied, no impulse in x direction. So therefore we can conserve the momentum in the x direction. So initial momentum of the system m plus capital M in x direction is equal to final momentum in x direction. So it is at rest before collision. What is the momentum? This is m into u plus 0. What is the final momentum in the x direction? Say m into v. V is the velocity, because after collision it is moving in this direction, vertical direction. So initial momentum is mu, right, and the final momentum is mv in the x direction. So the velocity of the wedge after collision, right, is mu upon capital M. This is the first question. Question you can write on your copy later, right? Try to understand and copy this. Okay, in the second part, what we have to find? We have to find this speed, right? How to find this speed? Listen, when the collision takes place, the impulse line of impact is in this direction. This is the surface. The impulse is applied on the block, on the wedge. This is the impulse applied. In the same way, the impulse is applied on the ball in this direction. The impulse is nothing but the change in momentum, right? Impulse, if you remember, the impulse t dt, right, like this. So what is happening? If you consider this is the line, the impulse on, if you consider the ball, the impulse is applied on the ball in this direction. So along this direction, the momentum of the ball will not change. So can you tell me, before collision, right? Before collision, if this is the u, this is theta, this is theta, what is the component of the velocity? Component of the velocity of this u along this direction. Say the component of the velocity is u cos theta. Is it clear or not? You tell. And after the collision, this ball become like this, but its component of this velocity remain as it is. This component remained u cos theta. Suppose this is the small v, right? We have to find the velocity of this ball. If this is theta, right, this is also theta, right, this is 90 minus theta and this is theta. Do you understand or not? You tell. So if I assume the velocity of the small ball in the vertical direction is v, but its component remains constant. If this is the u cos theta, after collision also it remains u cos theta. Now if this is v, so what, and this is theta, so if this is v, so after collision this component is v cos theta, and after collision this component is v sin theta. Are you getting or not? Right. So this is the v sin theta must be equal to u cos theta. V sin theta is equal to u cos theta. Therefore the v is equal to u cos theta upon sin theta, and therefore the speed of the ball after collision, this speed become u cot theta. This is the velocity of this ball. Copy. In the third part, you have to find the impulse imparted by the ball on the wedge. Listen, what the impulse is imparted by the ball along the common normal. This is the common normal. The same impulse is imparted by the wedge on the ball, but in opposite direction. Listen one thing. In the third part, if this is the wedge, right, and some impulse is imparted like this. Impulse means a sudden force acting upon this thud, and it will start moving with the speed v. Is it clear or not? You tell. So what is the definition of the impulse? If I consider the mass is m, right, the component of the impulse, if this is theta, right, this is 90 minus theta 9, and it is theta, this is integration of n dt. This is the impulse. This is the representation of impulse. Some teacher write impulse by integration n dt, or it may be written by j only, right? J is the impulse. Sometime it may be written as I vector, so no difference, right? Most of the book write the impulse by n dt, because the normal reaction acts for very short duration like this, right? And this area is called the impulsive force, right? So this is the impulse which is equal to change in momentum. So if this is n dt impulse, what is this component? Say n dt sin theta. Is it clear or not? Are you getting? This is the theta, 90 minus theta, and this is theta. Is it clear? So for the wedge, in x direction, suppose this is the x direction, in x direction, what is the impulse? Impulse applied n dt sin theta is equal to change in momentum. Impulse is nothing but, what is the impulse? Nothing but change in momentum. So the p final minus p initial. What is the final momentum? Say m into v. Is it clear or not? What is the initial momentum? It was at rest. So n dt into sin theta. So what is the impulse? N dt is equal to mv upon sin theta. So this is the impulse applied by the ball on the wedge. Because of this impulse, because of this sudden force, it start moving in this direction. So this is the answer, mv upon sin theta. And what is the velocity? The velocity acquired is what? This is the sin theta, right? And m into v. M into v is equal to what? Say m into u also. What is the u? U is the speed of this ball. So this is the impulse imparted by the ball on the wedge. Copy this. In this question, this is the impulse imparted by the ball to the wedge. Can you find the impulse imparted by the wedge to the ball? Yes. In the second method, I am telling. This is the method one. The impulse can be found with the help of this. Now, what is the impulse? You tell me. If you consider this is the ball, right? Is there any change in the momentum of the ball? The initial momentum of the ball is in this direction and the final momentum is in this direction. So why the momentum of the ball is changing? You tell. Because of some impulse. Are you getting or not? Because of some impulse would be applied on this ball. That is why its momentum is changing. What is the impulse formula? The impulse definition is the change in momentum. But we have to apply the change in momentum along the common normal. Listen one thing. The impulse is applied in this direction. Its momentum is not changing in this direction. Are you getting? For example, when we have done this type of question, if you remember this, right? So this component does not change. This component does not change. Only the impulse is applied in this direction. You may write the change in momentum in this direction, right? So you tell me, if you consider the ball is coming with the speed u and this is the angle theta. Which component? This is the u sine theta. When it hits the ball, when it hits the wedge, what is the component of this ball of mass m along the common normal? What is the component? Say its momentum in this direction. If you consider this the x-axis, y-axis, along the common normal, the momentum is mu sine theta. Are you getting or not? Now, after the collision, its velocity become v. So, what is the component of this? What is the component of the momentum along this direction? If this is theta, right? This is theta, 90 minus theta, 90 minus theta, this is theta, right? This component, this is theta, right? This is theta. So what is the component of the momentum? Say m into v cos theta. Are you getting or not? So if you consider the ball along the common normal, along common normal, can you find the change in momentum? Change in momentum. This is mu sine theta, this is mu sine theta, and this is mv sine theta. I think you know very well, this is mv cos theta plus mu sine theta. Both are added because this minus this. If you remember this, mu sine theta is the initial momentum minus, right, minus mu mv cos theta. Is it clear or not? You tell. Right, this is the p initial minus p final, right? So then mu sine theta plus v cos theta, m into u sine theta plus v. What is this? What is this speed? What is the speed of the particle in this direction? We have found. Yes, this is the speed of the particle. This is u upon cot theta into cos theta, right? So this is equal to mu sine theta plus u sine theta, because cos theta will cancel out. So this is what? Impulse is equal to this is cot, this is v is equal to u cot theta. Cot theta is equal to cos theta upon, right? So this is m is equal to u sine theta plus u cos theta upon sine theta into cos theta. If you take u common, mu sine theta plus cos square theta upon sine theta. When you multiply, this is mu, right, sine square theta plus cos square theta upon sine theta. It is equal to 1. So this is equal to mu sine theta. So the change in momentum is nothing but the impulse, right? So the impulse, what the impulse is applied on the wedge by the ball, the same impulse is applied by the wedge on the ball. The magnitude is same, only the direction will be the different. It will be applied in this direction, it will be applied in this direction. Do you understanding this thing? I have written P I minus P final, but the change in momentum is P final minus P initial, right? The magnitude I have to take. So this is the way, the same thing. The impulse is nothing but n dt. You can find with the help of the both the wedge, either from the wedge or the ball. Now, what is the what is the next part? See the coefficient of restitution. Coefficient of restitution. Can you tell me what is the definition of the coefficient of restitution? Coefficient of restitution. Restitution. Right. What is the definition of the E? The definition of the E is the velocity of separation divided by velocity of approach. Right? Velocity of approach. But when there is an oblique collision, you have to write the velocity of separation along common normal. Along common normal. Right. And the velocity of approach along common normal. Along common normal, why it is along common normal? Because the impulse is imparted along the common normal only. Are you getting or not? Can you tell me what is the velocity of approach along the common normal? What is the velocity of approach? Listen one thing. If I'm making the figure over here, right, before collision, this is the speed of u, right? So along common normal, by what velocity the ball is reaching in this direction? If this is theta, right? If this is theta, this is theta. No. This is u sine theta. It is, right? So by what velocity the ball is reaching toward the surface? Say u sine theta. So the velocity of approach along the common normal is u sine theta. Is it clear or not? Now after collision, this ball start moving with some speed v. Are you getting or not? If this is v, this is the v cos theta. So in this direction, it is moving with speed v cos theta. Is it clear or not? And this wedge is moving the speed capital V. Are you getting? This is the capital V. So if this is the capital V, this is theta. What is this component? This is the v cos theta and this is the v sin theta. So listen one thing. After collision, this wedge is moving in this direction with the speed v cos theta. Is it clear or not? Sorry, this is the theta, this is theta, this is v sin theta, and after collision this ball is moving away with the v cos theta. Is it clear or not? One ball is going in this direction and the wedge going in this direction with the v sin theta, v cos theta. Can you tell me what will be the velocity of separation? By what rate they are separated from each other along the common normal? This is the v cos theta plus this is the v cos theta, this is the v cos theta plus v sin theta. You understand this thing or not? You tell. Are you getting? This is the v, this is along the common normal, this is theta, so this is v cos theta and this is v sin theta. So this is the definition of the coefficient of restitution. Now we can put the different values and we can get the values of E. This, wait for 1 minute, I am making it correct. This is the V is u cot theta multiplied by cos theta plus V. The value of capital V is mu upon capital M into sin theta divided by u sin theta. Right. Now you may correct this. The u will cancel out. This is the cot theta, cos theta plus m upon capital M sin theta. This is the sin theta left, sin theta and sin theta. Right. So this is cos theta upon sin theta, cot square theta plus m upon capital M. Now it is correct. So this is the coefficient of restitution in this case. 10, whatever you have sent it is. This is the pulley. I'm explaining this. No need to read. This is the pulley and this is the mass M. Right. This is the B. And this is the mass 3M, suppose. This is the A. And a ball of mass M is coming with the speed U. Right. So they are asking what is the impulse imparted by the tension. Right. When it will hit. When it will hit. And the perfectly inelastic collision is over there. So this mass and M, it will stick. And this is the 3M. So initial momentum mv. So if it moving with the speed v dash, it is speed v dash. Can you find the common speed? How to find the common speed? Yes, tell me. Listen one thing. You can consider this is the system is like this. This is the m and the mass m is coming with the speed u. It hits the ball and stick with this inelastic collision, perfectly inelastic. So initial momentum is what? Initial momentum is mu. And when it is stick with this like this, so this 3m moving with the v dash and it is also moving the v dash. So what is the final momentum? 3m into v dash, 2m into v dash, that is the 5m into v dash. Are you getting or not? So therefore the initial and final momentum are same. So what is the initial momentum? Initial momentum is mu. When it stick, all the system start moving with the speed v dash, and 3m v dash plus m, 2m v dash. So what is the v dash? This is mu. So v dash is equal to u by 5. Is it clear or not, you tell? So the common velocity is the u by 5. Now what is the velocity just before the collision? Say initial velocity is 0, and what is the final velocity of just after impulse is applied? What is the meaning of the impulse? The impulse means a jerk is applied suddenly. So what is that? It is t dt. Sometime the impulse applied by the tension is represented by t dt, or in simple we can represent it by j. So because of this impulse, because of here is nothing impulse, when it just hit, is suddenly jerk due to the tension, which is called the impulse by the tension is applied. So what is the impulse? Impulse is nothing but t dt is equal to change in momentum. So what is the momentum, final momentum? Say 3m into v dash. What is the initial momentum? Say 0. So 3m into v dash. And what is the v dash? Say u by 5. So 3 by 5 mu is the impulse imparted by the tension to this ball. Is it clear or not, Utah? Copy this. So in this question, there is a wedge, right? And the mass of the wedge is capital M, and a particle of mass m hits wedge normally, right? This is the velocity of the particle. You can assume this is the velocity v naught, the mass m, right? And the coefficient of restitution is E. Now you have to find the velocity of the wedge and particle just after collision. Are you getting or not? So you have to solve this question. It is hit normally. This angle is theta, suppose. Find velocity of wedge. You can write down, find velocity of wedge and wedge. Find the velocity of wedge and particle just after collision. Just after collision, right? Just after. Take the coefficient of restitution is E, right? Copy this question. Yes. Did you copy this? Right. So what is the definition? Okay. So how to solve this question, you tell. Listen. Just after the collision, suppose this start moving, the wedge start moving with the speed v. When it hits the wedge over here, right, all the velocities along the common normal, initial velocity is v naught, and after the collision it start moving with the speed vn. Do you understand or not? In the same direction. Are you getting? Suppose this is the v1 velocity of the mass m. You are getting this thing or not? It will move in this way, it will move along this direction, it will continue to move with the speed v1 in the same direction. Is it clear or not, you tell? Right. So you tell me what is the momentum, right? What, in which direction we have to apply the momentum if you consider this as a system? You tell. In which direction you have to conserve the momentum, right? In x direction. If you consider this is the system, so in x direction, what is the, if this is theta, this is what? This is theta, 90 minus theta and theta. So this is what? Say v naught sine theta. So initial momentum in the x direction is equal to final momentum in x direction. So m into v naught sine theta must be equal to capital M into v. It is again moving with the speed v1, right? So if it is the v1 speed of the particle m, and this velocity is what? If this is the v naught, v1, what is the component? If this is theta, this is theta, this is again v1 sine theta. So m into v1 sine theta. This is the thing. Are you getting or not? So v1 is the velocity of the particle and capital V is the velocity of the wedge after collision. The wedge will move horizontally and the particle will continue to move in the same direction, because in this direction no velocity, an impulse is applied on this direction. So this is the one equation, right? The another equation we found with the help of the coefficient of restitution. What is the coefficient of restitution? Velocity of approach along common normal approach and velocity of separation along common normal, along common normal, along common normal. Do you understand or not? So can you tell me by what velocity the particle is approaching towards the wedge? Tell. What is the velocity of approach along the common normal? Varsha. V naught only, right? V naught. And after collision, the wedge is starting in this way and it is moving with v1. So what is the velocity of separation along the common normal? If this is the theta, right, this is the v sine theta and this is the v1. So along common normal it is moving with v sine theta in this direction and in this v1. So what is the velocity of separation? Tell me, what is the velocity of separation? V sine theta minus v1. V sine theta minus v1. Is it clear or not, you tell? V sine theta, if I assume this is the v1, then the velocity of the relative velocity is v sine theta plus v1, but I assume this is the mass m is moving with the speed v1 along the common normal. So v sine theta minus v1 upon v naught is the coefficient of restitution. Is it clear? Copy this. Okay, so we have the two unknown, the velocity v and the particle velocity v1. So it may be written as ev naught v sine theta minus v1. Now we can simplify this, right? So what is the value of v? This is the v1 is equal to v sine theta minus ev naught. I will put over here, and I can find, this is the equation number 1. From the equation number 1, mv naught sine theta is equal to m into v plus m into v1 v sine theta plus minus ev naught, right? Ev naught m into v1 and one more sine theta will be there. Is it clear? So this is m into v sine square theta minus m e v naught sine theta. So m v naught sine theta it is, right? M v naught sine theta. So when it will come out, come this side, m v naught sine theta plus m e v naught sine theta, and here I took the v common, capital M plus small m sine square theta. So m v naught sine theta is common. This is 1 plus e divided by v, m plus m sine square theta, right? So capital V, that is the speed of the wedge, is equal to mv naught sine theta 1 plus e upon capital M plus small m sine square theta, right? So this is the velocity of the wedge after collision. If you want to find the velocity of the particle, you just put over here. So v1 is equal to v sine theta minus ev naught. If you put the value, you will get the v1 also.